Hello everybody, this is Peter Klapper from BioChemSnacks, the bite-sized video snacks for all bioscientists. Have fun! Often people get confused about Ka and pKa of an acid. So let's just simply write down a normal equilibrium for an acid. So let's say we have an acid, Ha, and this then donates a proton, H+, and becomes the corresponding conjugate base. Now, if we wait long enough, then hopefully in an aqueous solution, we will get a nice equilibrium. And we can write this equilibrium as Ka, and this is the equilibrium constant. Equilibrium constant. And it's also very often called the dissociation constant. Dissociation constant of this particular reaction. And in the equilibrium, we would have the concentration of the protons. And sometimes we indicate that it is an equilibrium by putting this egg times the concentration of the base, also in equilibrium, divided by what is left of the acid in the still also in the equilibrium. And now if we have a very strong acid, what will happen? So in the case of a strong acid, we have the amount of protons and base is very high because the acid will pretty much dissociate more or less completely into proton and the base. So this is high, and what's left of the acid is pretty low. So we have something large divided by something small, and therefore we can say that the Ka of a strong acid is very large, and I indicate that with this symbol here. Likewise, if we have a weak acid, only a tiny little bit is dissociated into the proton and the base, and most of it will stay in the acid form, in the Ha form. So we have something small divided by something large, and that of course would give us something small. So for a weak acid, Ka would be very low. And I write it like that. Now, very often people don't really like to work with Kas in that form. So therefore, they come up with this different writing, and a definition for that is pKa is the negative log to the basis of 10 of Ka. So this means, since we've got a negative here, if the Ka is large, then our pKa is very low. So pKa is very small. And if the Ka is small, then the pKa is very high. Now let me give you an example for that. Let's say we have an acid again, and I write that Ha gives H plus A minus, and we have a Ka of, say, 10 to the minus 5, and usually this would be molar. So this means that we have H plus times A minus divided by Ha, and all is in the equilibrium, and that is 10 to the minus 5 molar. So that means we have just a little bit of that, but most of it is in this form here. And the pKa for that is minus log of Ka. So in this case it would be minus log of 10 to the minus 5, and that would give us pKa of 5. And anything that has a pKa, if the pKa is larger than usually, say 2, then this is considered a weak acid. Thanks for watching, and see you soon again at BioChemSnacks. Bye bye!